Measurements of length. Length is a measure of distance. The tool used to measure length is a ruler. Meter is the base unit of length, and the abbreviation for meter is M. Decimeter, a unit of length equal to 1/10 of a meter, and the abbreviation for decimeter is DM. Centimeter, equal to 1/100th of a meter. And right here, that's a centimeter. These 10 little lines right here. Millimeter, 1/1000th of a meter, and the abbreviation for millimeter is MM. As you can see right here, a millimeter is one line right here. As a centimeter is right here, 0 to 1. A millimeter is the little lines in between. Measurements of mass. Mass is the amount of matter in an object. The tool to measure mass is a triple beam balance. A kilogram, the base unit of mass. The abbreviation for kilogram is kg. Measurements of mass. Gram, equal to 1/1000th of a kilogram. The abbreviation for gram is G. Milligram, equal to 1/1000th of a gram. The abbreviation for milligram is mg. Measurements of volume and density. Volume is the amount of space in an object an object takes up. Liters, the base unit of volume. The abbreviation for liters is L. Millimeters, 1/1000th of a liter. The abbreviation for milliliters is ml. The tool used to read this is a graduated cylinder. This is a graduated cylinder right here. The meniscus, a curve on top of the liquid. The meniscus is this little curve that forms right here, and it forms because of the cylinder has an attraction and it like makes it a little curve. Measurements of density. Density, the amount of mass per unit. As you can see right here, the box to the right is more dense than the box to the left because they're more close together, and this is less separate. Atoms, ions, and isotopes. An isotope is an atom, and an ion can be an atom or molecule. They can all be atoms. The number of electrons in a neutral atom is equal to the number of protons. This right here is an atom. Protons are these little orange things, and the neutrons are these little gray things, and the electrons are the blue things around. Valence electrons. Valence electrons are the furthest most electrons from the nucleus in the outer shell. For neutral atoms, the number of valence electrons is equal to the atom's main group number. For example, boron is in group 3 and has 3 valence electrons. Valence electrons increase in number as you count groups left to right, if it's not a transition metal. Right. The valence electrons are these little things, are the electrons that are all the way in the outside. These are shells, these little lines, these are called shells. And here's a periodic table. As you can see, the group 1, 2, you don't count these because these are transition metals. 3, 4, 5, 6, 7, and 8. And valence electrons are the most important electrons in an atom. Coulomb's law. An object with greater charge will exert a greater force on an object that an object with a smaller charge would. But if both charges are the same, they will exert equal to each other. If the distance is doubled, the force of gravity is 1/4 as strong as before. Periodic table patterns. Atomic radii is the size of an atom. It decreases from left to right. It increases from top to bottom. The pattern happens because electrons keep adding to the shell. Alright, right here. See, the atoms from left to right, they decrease from left to right. And from top to bottom, they increase. Ionization energy, the amount of energy to remove an electron from an atom. From top to bottom, the ionization energy decreases because a valence shell is being added, so it is easier to remove an electron. From left to right, the ionization increases because the electrons are closer to the nucleus, so it's harder to remove an electron. Alright. So the electrons in these over here, in this part of the periodic table, they're harder to remove an electron because they're closer together, even though they might be smaller. And here, the electrons here, this is the biggest one, is easier because the shells are more separate from the nucleus, so it's easier for them to get removed. Electronegativity, the measure of an atom's attraction to electrons. It increases from left to right because there are more positive protons in the nucleus, creating a stronger pull. It decreases from top to bottom because the distance between the valence electrons and the shell of the nucleus. Bonding. Ionic bonding. Electrons get stolen and opposite charges attract. Ionic bonds occur between metals and nonmetals, for example, sodium and bromide. Covalent bonding. They share electron pairs between atoms. Covalent bonds occur between nonmetals.